At first, it looked like nothing more than a faint streak of light. But when scientists calculated its trajectory, they realized this object was not from our solar system. It was moving at roughly 221,000 kilometers per hour, traveling far too quickly to be captured by the sun's gravity. Whatever this object was, it had entered our solar system from interstellar space. That immediately made it extremely rare. Before this discovery, humanity had confirmed only 2 interstellar visitors. The first was Oumuamua, discovered in 2017, followed by comet Borisov in 2019. Oumuamua was strange because it behaved differently from ordinary comets. It showed unusual movement, yet astronomers could not clearly identify the normal signs of cometary activity. Borisov was much easier to understand. It looked and behaved like a comet, complete with a cloud of material surrounding it. Then came 3I, Atlas. This new visitor was different again. As soon as its path was confirmed, astronomers around the world began observing it. Telescopes that normally spend their time studying distant galaxies, planets, stars and asteroids were redirected toward this single object. The reason was simple. They had only one chance. 3I, ATLAS was passing through our solar system, but it would not stay here. After moving around the Sun, it would continue back into interstellar space, never returning. Hubble eventually captured detailed observations of the comet. The images showed a bright cloud of dust and gas surrounding its solid nucleus. Determining the exact size of that nucleus was difficult because the surrounding material made the central body difficult to see. Later observations suggested that the nucleus could be around a few kilometers across. That might sound small compared with a planet, but this was not an ordinary piece of rock. It had come from another stellar system. Somewhere far away, around a star we may never identify, this object had formed, frozen and eventually been thrown into interstellar space. Then it traveled through the darkness for an enormous amount of time. The most interesting part came when scientists began analyzing its chemistry. James Webb Space Telescope examined the gases surrounding the comet and detected several important molecules, including water vapor, carbon dioxide and methane. Scientists also found unusual isotope ratios. One particularly interesting measurement involved deuterium, a heavier form of hydrogen. The amount appeared unusually high compared with many comets known from our own solar system. This suggested that 3I, ATLAS may have formed under conditions very different from those that produced the comets around our Sun. And that raised a much bigger possibility. The object could be extremely old. Some scientific estimates suggested that its material may have formed billions of years before our solar system existed. Think about what that means. The Sun is about 4.6 billion years old. Earth formed roughly 4.5 billion years ago. But if 3I, ATLAS really originated during an earlier period of the Milky Way, then this small frozen body could have existed before the Sun was even born. It may have spent billions of years traveling between stars, carrying chemical material that had remained frozen for an unimaginable length of time. When it finally entered our solar system, sunlight began warming its surface. Ice turned into gas. Dust and other material escaped from the nucleus. And for a short period, this ancient traveler effectively revealed what was hidden inside it. The chemical evidence suggested that its birthplace was extremely cold. Some researchers estimated formation temperatures below 30 Kelvin, which is around -243 degrees Celsius. In such an environment, volatile compounds can become trapped in ice and remain preserved for enormous periods. That makes an interstellar comet incredibly valuable to scientists. It is almost like receiving a natural sample from another planetary system without ever traveling there. But the chemistry also created a new mystery. 3I, ATLAS contained molecules that are important when scientists study the origins of life. Water and carbon-based compounds can participate in chemical reactions that eventually produce more complex organic molecules. This does not mean the comet contained life. There is no confirmed evidence of organisms inside it. But it does show that potentially important chemistry exists beyond our solar system. And that leads to a fascinating question. If these molecules can form around other stars, how common are the ingredients needed for life throughout the galaxy? The answer could change how we think about our own planet. Maybe the chemistry that helped life emerge on Earth is not unique. Maybe similar ingredients are scattered throughout the Milky Way, traveling inside frozen objects just like 3I, Atlas. And this is only the beginning of the mystery. Because while the comet's chemistry can be studied, its birthplace remains hidden. We may never know which star system created it. We may never know exactly how long it wandered through space. But we do know one thing. For a brief moment in 2025 and 2026, an object from another star system entered our cosmic neighborhood. Humanity watched it. We measured it. We studied its ancient chemistry. And then, just as quickly as it arrived, it began disappearing back into the darkness. The most surprising clues from 3I, Atlas came from the chemistry surrounding its nucleus. James Webb Space Telescope detected methane along with water vapor and carbon dioxide. Methane immediately attracted attention because, on Earth, it can be produced by both geological processes and living organisms. But this distinction matters. Finding methane does not mean scientists found life. Methane can form naturally without biology, so researchers need much more evidence before connecting it to anything living. Still, its presence added another unusual detail to an already remarkable object. Scientists were also interested in the ratios between different molecules. The comet appeared to contain a chemical mixture that was not identical to what we normally see in comets originating from our solar system. That difference may tell us something about where the object formed. Every planetary system develops under its own conditions. Temperature, radiation, available elements and the presence of larger planets can all influence the chemistry of smaller bodies. If 3I, ATLAS really formed billions of years before our solar system, then its chemistry could provide a glimpse into an ancient stage of the Milky Way. It would be like opening a frozen archive from a time long before Earth existed. And there was another important clue. The object's enormous speed suggested that something powerful may have ejected it from its original planetary system. A close gravitational encounter with a giant planet could have changed its orbit dramatically, throwing the comet away from its parent star. Once released, there would have been nothing keeping it inside that system. It became an interstellar traveler. For billions of years, it could have crossed the space between stars until gravity eventually placed it on a path through our solar system. That journey is almost impossible to imagine. Our entire recorded human history occupies only a tiny fraction of the time this object may have existed. Civilizations appeared and disappeared. Languages change. Cities were built and abandoned. Human beings developed science, technology and telescopes capable of detecting distant worlds. Meanwhile, somewhere in the darkness, this frozen object continued moving. Then our sun became the next star it encountered closely enough to change its surface. As it approached the sun, its ancient ice began releasing gas and dust. That activity allowed telescopes to examine material that had been locked away for billions of years. This is why interstellar comets are so valuable. Instead of studying another planetary system from thousands or millions of light years away, scientists can examine material that actually entered our own neighborhood. Of course, 3I, ATLAS also attracted attention because of claims that some of its unusual characteristics might have an artificial explanation. Harvard astronomer Avi Loeb has argued that unusual properties of some interstellar objects deserve serious investigation, and he has raised the possibility of technological origins. But that is very different from saying that an alien spacecraft has been discovered. There is currently no confirmed evidence that 3I, Atlas is artificial. Radio searches have not revealed a verified technological signal from the object. No artificial structure has been confirmed. The strongest scientific interpretation remains that 3I, Atlas is a natural interstellar comet. And that conclusion does not make it boring. In fact, the natural explanation may be even more important. If an ordinary comet can survive for billions of years, leave its original planetary system, cross interstellar space and still preserve ancient chemical information, then the galaxy may contain countless natural time capsules like it. Some could be passing through our solar system right now without anyone noticing. The discovery of 3I, ATLAS may therefore represent the beginning of a new era. Future telescopes could detect more interstellar objects, allowing scientists to compare their chemistry. Instead of studying one strange visitor, researchers might eventually have dozens or even hundreds of examples. That would help answer one of the biggest questions raised by 3I, Atlas. Is our solar system chemically normal? Or is the chemistry around our sun unusually different from what exists elsewhere? The answer could tell us something about how planets and comets form throughout the galaxy. It could also help scientists understand how the ingredients associated with life are distributed through space. Because water and organic compounds are not necessarily limited to Earth. They can form in cold clouds, freeze into icy bodies and survive inside planetary systems for enormous periods. If these objects are later ejected, their chemical material can travel between stars. That means the galaxy may not be a collection of completely isolated planetary systems. Instead, material could occasionally move from one system to another. 3I, ATLAS became a powerful example of that possibility. It arrived carrying chemical information from somewhere we may never identify. It passed through the solar system. It came close enough for our most advanced instruments to study. And then it continued outward. By the time future generations examine the object again, it will be far beyond the planetary region of the Sun. We cannot simply wait for it to return. It never will. But the information it provided remains here. Every